Hello everyone, my name is Manvi Sinha and I study in Sri Venkateshwara College of Engineering. My USN is 1VE23IS028 and my subject name is Object Oriented Programming with Java. Its code is BCS306A. Today I will be discussing a crucial concept in Java programming, threads. Threads are independent units of execution that allow Java programs to perform multiple tasks simultaneously, enhancing performance and responsiveness. In this presentation, we will cover what threads are, the life cycle of a thread, how to create and manage threads in Java, and the benefits of using multi-threading in real-world applications. Let's start with a basic definition. A thread is a small, lightweight process that operates within a program. Unlike traditional process, threads within the same application share memory and resources, making them more efficient. In Java, multithreading enables a single program to run multiple tasks concurrently, which can be particularly useful for large, complex applications like games, web servers, and real-time processing. In simpler terms, think of a thread as a single sequence of actions that the CPU can handle separately from other sequences in a program. Java has built-in support for multithreading, allowing developers to create and manage threads with ease. With multithreading, Java can run multiple tasks at once, significantly improving the responsiveness of applications. This is especially important for applications that need to perform background tasks such as loading data without freezing the main user interface. Java's multithreading capabilities make it a popular choice for high-performance applications. This is particularly important in Java as it is defined with built-in support for multithreading through the java.lang.thread class and the runnable interface. This support allows Java applications to be more responsive and efficient by managing tasks separately. So, why should we use threads? Threads help improve application performance, responsiveness, and resource utilization. For instance, in a video game, threads can handle graphics rendering, sound processing, and user input simultaneously, creating a smooth experience for the users. By running these tasks concurrently, threads ensure that applications are responsive and efficient. Some of the things which includes are concurrency and parallelism, improved application responsiveness, efficient resource utilization, simplified program structure for complex tasks, real-time data processing. The thread life cycle in Java has 6 primary states. First one is new. A thread is in the new state when it first creates but hasn't started executing. Second one is runnable. When a thread's start method is called, it enters the runnable state, meaning it is ready to run but may not be executing yet. Third one is blocked. A thread enters the blocked state if it tries to access a resource that another thread currently holds, such as synchronized block or method. Waiting. The waiting state occurs when a thread is waiting indefinitely for another thread to perform a particular action. Timed waiting. A thread enters the timed waiting state when it calls methods with a timeout. Terminated. A thread reaches the terminated state when its execution finishes, either by completing its task or encountering an unhandled exception. Every thread in Java goes through a life cycle which includes several states. These states are new, runnable, blocked, waiting, timed waiting, and terminated. When a thread is first created, it's in the new state. When it started, it moves to the runnable state, waiting for CPU resources. While running, if it encounters a condition that prevents it from proceeding, it may move to the blocked or waiting state. Once the task is completed, the thread reaches the terminated state. Understanding this cycle is essential for effectively managing thread behavior. In Java, we can create a thread in two primary ways: by extending the thread class or by implementing the runnable interface. Let's start with extending the thread class. This approach involves creating a new class that extends thread and overrides the run method, where we define the task for the thread. Alternatively, we can implement the runnable interface, which also requires us to define the run method. We then pass an instance of this class to a thread object and call the start method. While both approaches are effective, implementing runnable is often preferred as it allows for greater flexibility and doesn't restrict inheritance. There are some key methods in Java that help us control thread behavior. Start. This method initiates a thread, calling the run method to begin the thread's execution. Run. This method contains the code that the thread executes when the start method is called. It automatically invokes run. Sleep. This method pauses the execution of the current thread for a specified number of milliseconds, allowing other threads to execute. Join. This method allows one thread to wait for the completion of another. Interrupt. This method interrupts a thread, signaling it to stop. This is especially useful when you want to stop a thread that's in a sleeping or waiting state. The start method initializes the thread and automatically calls the run method. The run method contains the code that the thread will execute. We can use the sleep method to pause a thread for a specified period, allowing other threads to run. We can use the join method. One thread waits for another to finish, which can be useful when we have dependencies between threads. Lastly, the interrupt method allows us to stop a thread, especially if it's in a waiting state, which helps manage thread execution gracefully. One important concept in multithreading is synchronization. When multiple threads try to access a shared resource simultaneously, it can lead to data inconsistency and race conditions. Java provides the synchronized keyword to prevent this. By marking a method or code block as synchronized, only one thread can access it at a time. This ensures data integrity and consistency. For instance, in a banking application, synchronization prevents multiple threads from modifying an account balance at the same time, avoiding errors. Synchronization ensures that only one thread can access a critical section of code. Example, modifying a shared resource at any given time. This prevents race conditions and ensures data integrity. Threads have many real-world applications. In gaming, threads handle different tasks like rendering graphics, managing AI, and processing user input, creating a smooth experience. Web servers use threads to manage multiple client requests simultaneously, ensuring quick response times. In real-time data processing, threads process live data streams without delays, which is critical for applications like stock trading. These examples show how threads are essential for building responsiveness, scalable applications. Why is it beneficial to understand threads in Java? First, it helps us develop high-performance applications. With multi-threading, we can ensure efficient resource utilization, making programs faster and more responsive. Second, it builds our problem-solving skills as we learn to manage concurrent tasks. Additionally, threading knowledge is valuable for interviews and can enhance career opportunities, especially in fields like software development and system design. To summarize, threads are independent units of execution that enable concurrent processing in Java. We discussed the thread life cycle, methods to create threads, essential thread management methods, and the importance of synchronization. Understanding these concepts always allows us to build responsive, efficient applications that can handle multiple tasks at once. Threads are widely used in gaming, web servers, and real-time data processing, making them a valuable skill in the modern software development work. Understanding threads in Java enables you to build faster, more responsive, and resource efficient applications, equipping you with skills critical in various software development areas. So, thank you for watching. I hope this presentation helped clarify the concept of threads in Java and their importance. By understanding threads, we gain the ability to create faster, more efficient, and scalable applications. Whether you are building a game, a server, or a data processing system, threading is an essential skill that can elevate your programming capabilities.